Determine whether the set S spans R3. If the set does not span R3, then give a geometric description of the subspace that it does span. So if you look at this set S with the four vectors, if I call V1, V2, V3, V4, what we need to do is, are there three linearly independent vectors in there? We need three linearly independent vectors. But right away, I see that V4 is twice V1. So V4 doesn't really give us any new information. Okay, so we can ignore that vector because that is linearly independent of V1. So we can think of just V1 and V2 and V3. So are these linearly independent? That is the question. Okay. So to check whether they are linearly independent, so I do C1 V1 plus C2 V2 plus C3 V3 equal to 0. And if they give me C1 equal to 0, C2 equal to 0, C3 equal to 0, then what? Linearly independent? And then therefore spans R3. Okay, so we'll check that. So C1 103 plus C2 20 negative 1 plus C3 of 405 is 0 0 0, 0 vector. So let's solve this for C1 C2 C3. So C1 plus 2C2 plus 4C3 equals 0. Now the second one is C1 0 is 0, C2 0 0, C3 0 is 0. So that second equation doesn't give me any new information. So we'll go to third one, which is 3C1 minus C2 plus 5C3 equals 0. So we deal with these two equations. So now if I look at this C1, C2, C3, I want to eliminate C2. So I'm going to multiply this guy times 2. So I get 6C1 minus 2C2 plus 10C3 equals 0. That way I can eliminate C2 by adding these two equations. I mean, this equation and that equation. So I have 7C1 plus 14C3 equals 0. What that means? That means 7C1 equal to negative 14C3. That means C1 equal to negative 2C3. Now what about C2 then? So from that equation, C2 equal to 3C1 plus 5C3, but C1 is negative 2C3. So this is 3 times negative 2C3 plus 5C3 is negative 6C3 plus 5C3 is negative C3. Okay, so we have this situation. C1 is negative 2C3, C2 equal to negative C3. So if I write in this vector notation C1, C2, C3 is C1 is negative 2. So if I call this negative 2t, C2 is negative, so negative t, and let t equal C3, okay? Then C3 is just the t. So that means t, -2, -1, and 1. We have infinite choices of C1, C2, C3. Definitely infinite choices of C1, C2, C3. So if I let, say, t equal 1, that means C1 equal to -2, C2 equal to -1, and C3 equal to 1. Then what happened? -2 times the V1, which is 103, minus V2, which is 20 -1, and plus C3 1 times 405 equal 1. In other words, any vector, -2, let me put it this way, V1 minus V2 plus V3, this is equal to 0, equal to 0. Zero vector, that's what I mean. That means any vector can be written, so, V2 is -2 V1 plus V3, or V1 is, V1 is like 1/2 negative V2 plus V3. V3 is 2V1 plus V2. So it is only two vectors. That means only two vectors are independent. Okay, either V1, V2, or V1, V3, or V2, V3. Only two vectors are independent, not three. So the set does not span R3. Instead, because only two vectors, the set spans R2. Meaning what? It spans a plane in R3. Okay. So, for example, how about what V1? What was V1? V1 was 103, and then V2 is 201. So, what these two V2? So, what these span? If I draw a little picture, so 103 is like 1, 0, and 3. So it is this vector. 201, 201 is span this. So plane. So think about plane. Determined by these two vectors. You have to kind of picture it. Okay. Okay. So this picture is always y coordinate is 0. This y coordinate is 0. That means this plane is on xz plane, xz plane. This is y, this is x, and this is z. So it is like, like, I don't know, maybe like this. It's okay. Whatever you choose point, the y coordinate is always 0. Okay. X and z can be any value, but y coordinate is 0. So this is what we call xz plane. Okay, so it spans R2.